this graphical abstract particularly gives you an idea of what is the research is going to be about. So we would like to harvest wind energy and based on our locality. So to manage the wind energy system, or use nanogrid, or I don't know, want to be off grid, national grid, utilizing it in any industrial sector, agriculture, or something like that. So to have overall management of wind energy systems in a locality, we have to focus how we could become more efficient. That is why this research is giving you an idea about. So, well, before I move on to the research, I would like to say that this in video record also available in encyclopedia. You can also read as a report in the encyclopedia, or if somebody has interest reading the detailed article, you can also find it online. I also put the link in the description, so you can find them as well. Ignoring the local information from Bangladesh at this moment, the objective of the research is just to particularly assess the wind speed at any given heights, and based on the wind intensity, we would like to predict wind energy. So still second option is that let us ignore at this moment any energy consumptions in the country or any locality, or future projections, how necessity it is or being sustainable. So let us move to developing the statistical and predictive model for wind energy from the wind intensity. As we know, the physics equation, for example, wind velocity is exponent to the power. In other words, power can be projected proportional to the exponent of wind speed. By, as we also know, the wind intensity is actually increases exponentially as we increase the height. So those sort of physics phenomenon in the nature can help us develop. By ignoring the fact of wind turbine itself, we still can take the relationship of this physics phenomenon to implement into statistical, for example, exponential equation, or for an example, polynomial equation with order 3, so that still keeping the fact of physics phenomenon, so that we can develop a statistical simple predictive model for predicting wind energy based on wind intensity. So the wind intensity can be at any given height at any locations. So this statistical model, which is named as SPPM, can be predicting wind energy at any location. So it can tell us that if my location is suitable for harvesting wind at what height, so my wind turbine should be at what hub height, or my I should locate at what area, so that I can maximize the wind speed in that area and I can cash on more energy. So this model is particularly developed from all the 64 districts in Bangladesh, taken also datasets from India subcontinent, and very gentle wind or low wind speed. If you look at Papua New Guinea, those data also taken, and also Denmark and Netherlands, these are very dynamic and high wind speed. So those wind intensity and power relationships are obtained from Global Wind Atlas for developing, training the statistical model, and eventually compared with the physics-based model. So let us look into another consideration factor, boundary layer height, not to be ignoring before installing the wind turbine. But our more details discussions are how, even if we test for global wind atlas data for these locations from our trained model and predict the wind power, how it is forecasted. At the same time, we can take now any data sets, because the model is being trained. So I tested with ERA 5 data sets. Well, the height you see here is actually converted from hectopascal to the meter. There is a conversion, so please look at the paper as well. And wind power is predicted based on those wind intensity. And obviously that is how we can tell that wind power can be predicted at any locations with any given heights, and show how feasible your location is to theoretically understand power and all. So we can predict by using any data sets from the numerical models or Google data sets for weekly or monthly package, and provide wind power for any given location. And this is a final test that we predict annual energy production. So we took our year data sets from era 5, hourly data sets, and used the statistical SPPM model. And if you look into that, how polynomial has capacity of predicting about 84 to 90%, 97% higher accuracy than the all other exponential or physics model after all those assessments. So eventually, this simple power predictive model SPPM is useful enough for theoretically understand a suitable location for power, how much power is available, can be available at peak hours, or also it can be useful, very useful for managing wind power plants, and also at the same time utilizing the weather stations data for providing an extra business for handling wind power estimations. And also this research should acknowledge the limitations that it is only considered wind speeds at various heights and estimated power. So we also equally have to respect wind turbine technology, the development in the wind turbine technology, battery conditions, and also mechanical informations on the wind turbine. So we should come up together and help each other, working together for being robustness in the model predictions and as well as wind research. So I would like to conclude here. Thank you very much.